Ever wondered how data gets structured in databases? Ever heard about something called an entity relationship diagram, or ERD? Let's dive in. Entity relationship diagrams, or ERDs, are graphical representations of the entities or objects and the relationships between them within a specific domain. They are the blueprints of database design and systems analysis, providing a clear picture of the structure and behavior of data in an information system. Now, what makes up an ERD? There are four main components: entities, attributes, relationships, and keys. Entities are real-world objects or concepts that we store data about in the database. They are typically represented by rectangles with their names inside. For instance, customer, order, product could all be entities in a business database. Attributes are characteristics or properties of these entities. They describe the data we store about each entity. If customer is an entity, name, address, phone number might be the attributes. They are represented as ovals connected to their respective entities. Next up are relationships. These define how entities relate to each other. For example, a customer might place an order. Relationships can be one-to-one, one-to-many, or many-to-many, and are depicted as lines connecting the entities. Finally, we have keys. A key is an attribute or set of attributes that uniquely identifies each instance of an entity. Primary keys are attributes that uniquely identify an entity, while foreign keys are attributes in one entity that refer to the primary key of another entity. Understanding these components is the first step in comprehending the intricate structure of databases. With this foundation, you can begin to appreciate the complexity and beauty of data organization. But remember, this is just the tip of the iceberg. There's so much more to explore and understand about ERDs, from the types of relationships to cardinality and participation constraints. So stay tuned as we delve deeper into the fascinating world of entity relationship diagrams. Now that we know what an ERD is, it's time to understand each of its components in detail. First up is the entity. Think of an entity as a real-world object or concept. It's the primary building block of an ERD, and it's represented by a rectangle with its name inside. For instance, in a university database, student, course, and instructor could all be entities. Next, we have the attribute. This is a characteristic or property that describes an entity. So, for a student entity, attributes could be student ID, name, or age. Attributes are represented as ovals that are connected to their respective entities. Then there's the relationship. This defines how entities are connected to each other within the database. For example, a student enrolls in a course, or an instructor teaches a course. Relationships are drawn as lines connecting the participating entities, with cardinality indicators like 1 or M showing the degree of the relationship. Lastly, we have the key. A key is an attribute or set of attributes that uniquely identifies each instance of an entity. There are two types of keys, primary and foreign. Primary keys are underlined in the entity and uniquely identify each instance. On the other hand, foreign keys are attributes in one entity that refer to the primary key of another entity. They help to establish and enforce relationships between entities. Now let's look at an example to tie all these components together. Suppose we're creating an ERD for a university database. We'd start by identifying our entities: student, course, and instructor. Next, we'd list out the attributes for each entity. For student, we might have student ID, name, and age. For course, we'd have course ID, title, and department. Then we'd define the relationships. A student enrolls in a course and an instructor teaches a course. We'd represent these relationships with lines connecting the entities. Finally, we'd identify the keys. Student ID could be the primary key for the student entity, and course ID could be the primary key for the course entity. If we wanted to show that a student is enrolled in a course, we might add course ID as a foreign key in the student entity. These components come together to form the ERD, a comprehensive representation of data in a system. Understanding these components and how they interact is crucial to creating an effective and accurate ERD. In the next scene, we'll delve deeper into the types of relationships in an ERD, so stay tuned. Relationships are not just for people, they're essential in databases too. Let's understand the different types of relationships in an ERD. First up, we have the one-to-one relationship, the monogamous couple of the database world. In a one-to-one relationship, each instance of one entity is linked to exactly one instance of another entity. Picture a world where every book has a unique author and every author has written just one book. That's a one-to-one relationship. Next is the one-to-many relationship, a bit like a celebrity with their fan base. In this relationship, each instance of one entity is associated with multiple instances of another entity. Think of an author who has written many books. The author is one, the books are many. But remember, it doesn't swing the other way around. Each book still only has one author. Finally, we have the many-to-many relationship, the social butterfly of relationships. In a many-to-many relationship, multiple instances of one entity are linked to multiple instances of another entity. Imagine a book club scenario. Each book can be read by many members, and each member can read many books. It's a two-way street. But why do we need these relationships? They're crucial in helping us understand how different entities interact within a database. They show us how data flows, how it connects, and how it's accessed. They're the glue that holds our information system together. In the world of databases, nothing exists in isolation. Every piece of data is part of a bigger picture, a larger story. And relationships? They're the narrative thread weaving it all together. With a solid grasp on one-to-one, one-to-many, and many-to-many relationships, you're well on your way to understanding the intricate web of connections within an ERD. These relationships help us understand how different entities interact with each other in a database. Cardinality and participation constraints are two key concepts in ERDs. But what are they? Diving into cardinality first, it's all about numbers. Cardinality dictates how many instances of an entity can be associated with instances of another entity. Think of it as the numerical aspect of a relationship. For instance, in a one-to-one relationship, the cardinality is 1. This means that one instance of entity A is related to one instance of entity B. Similarly, in a one-to-many relationship, one instance of entity A can be related to many instances of entity B. Cardinality is often depicted using cardinality indicators such as 1, M for many, 0, or N for any number. Now, let's shift our focus to participation constraints. Participation constraints, unlike cardinality which focuses on numbers, are all about the necessity of a relationship. They determine whether the participation of an entity in a relationship is mandatory or optional. In other words, they define whether an entity must participate in a relationship or if it can choose to opt out. Let's consider a practical example. In a university database, we have a student entity and a course entity. The relationship between these two entities could be enrolls in. Now, the cardinality of this relationship could be one-to-many, meaning one student can enroll in many courses. But what about the participation constraint? Is it mandatory for every student to enroll in a course? Or is it optional? If it's mandatory, we have a total participation constraint. If it's optional, we have a partial participation constraint. These constraints, cardinality and participation, are essential in designing an ERD as they provide a clear and precise understanding of the relationships between entities. They prevent ambiguity and ensure the accuracy of the database design. With the right combination of cardinality and participation constraints, we can accurately define the extent and nature of relationships between entities, making our ERDs more effective and our databases more efficient. With these constraints, we can define the extent and nature of relationships between entities. We've covered a lot about ERDs, haven't we? Let's summarize the key points. An entity relationship diagram, or ERD, is a visual tool used to model the structure of data within a domain. It's comprised of entities, which represent real-world objects or concepts, and attributes, which describe the data stored about those entities. Then we have relationships, which define how entities interact with each other, and keys, which uniquely identify each instance of an entity. Relationships in ERDs can be one-to-one, one-to-many, or many-to-many, and they're graphically represented with lines and cardinality indicators. We also discussed cardinality, which indicates the maximum number of instances that can be associated between entities, and participation constraints, which dictate whether an entity's participation in a relationship is mandatory or optional. With these foundations, you're now well equipped to understand and create your own entity relationship diagrams. Remember, practice makes perfect.